Is going to look at the types of magma and lava. I know in class today on the board I had said eruption notes. We're going to move the notes on types of eruptions to tomorrow because I realized we need to talk about the types of magma and lava first, because it turns out not all magma and lava is the same. There are several different types and they behave very differently. So we're going to talk tonight about what causes different types of magma and lava to be different from each other and how those types of magma and lava will behave. So first, I want to talk about a mineral called silica, right? Which is important because it's going to end up determining a lot about the magma that we're going to look at. So silica is a mineral that makes up some percentage of most rocks in the crust. So almost any rock you pick up has some silica in it. Some rocks have a lot of silica mixed in. Some rocks don't have a lot of silica mixed in. They might have other types of minerals that are taking up other amounts of the rock. So just to kind of give you a visual, quartz, right, that clear, very hard mineral, is pure silica. So silica is just another term for quartz, but when we talk about it mixed in with other stuff, we usually call it silica. So quartz is pure silica. Almost all other rocks have other minerals mixed in as well. So granite has some amount of silica in it. Basalt has some silica in it. And so different rocks will have different amounts of silica depending on the rock. All right, so that's what silica is, and now we're going to see how it affects magma and lava. And it turns out that there are basically two main types of magma, and the big difference is how much silica they have in them. And so the first type of magma we have is called granitic magma. Right? So if you were to guess, you would probably guess that this forms granite when it cools, and you would be right. Right, so it's basically melted granite. It's very high in silica and creates a lighter colored lava. Now it's tough to tell looking at the lava because it's so hot that it's red, but when the rocks cool from granitic magma, they're going to be light in color. So you might want to add that to your notes, light colored rocks. And it has a high what we call viscosity. We'll talk about that term a little bit more on the next slide. Basically means it can't flow very far, so it doesn't flow very easily. So that's one type of magma, granitic magma. And our next is basaltic magma. All right, basaltic magma has less silica. It's low in silica compared to granitic. It forms dark colored rocks when it cools, right? Turns out silica, think about quartz, right? Quartz is a very light color, it's clear. So if you don't have a lot of silica, you don't have a lot of quartz, your rock is going to be fairly dark when it cools. And basaltic magma, it turns out, has what we call a low viscosity, meaning it flows readily. Right? So, granitic, high in silica, light colored when it cools, high viscosity, we'll talk about that more in a second. Basaltic, low in silica, dark colored when it cools, low viscosity. So let's talk about this thing, viscosity. So viscosity is what we call it the resistance of a liquid to flowing. So it's basically how much this liquid doesn't want to flow. So I'll give you an example of a low viscosity liquid would be water. Right? Water flows very easily. High viscosity liquid might be syrup. Right? Syrup, if you were to pour it out, isn't going to flow out as quickly as water will. Right? So what we say that water has a lower viscosity because it is less resistant to flowing. So for magma, viscosity is going to depend on silica content and the temperature, so how much silica is in the magma, and also how hot the magma is. And so let's look at these two things. Silica content is going to affect our viscosity, right? And I like to say that silica is sticky. Right? It's a good way to remember it. So silica is sticky, so if you have a high amount of silica, you're going to have a high viscosity for your magma, and that magma is going to be very sticky. It's going to be very syrup-like. It's not going to want to flow. Right? And for magma, when we say magma is high viscosity, it's like peanut butter. Right? It's very, very sticky. It doesn't want to flow at all. Lower silica is going to be a lower viscosity and is going to flow much more easily. Right? Then it's going to flow easily out of a volcano and down the hill. And this is kind of what you think of when we think of lava flowing. We're going to have low silica magma. Temperature can also affect viscosity. Right? If you heat it up, viscosity rather is going to increase as the temperature goes down. So as you cool off magma, it's going to become stickier and stickier. Right? And you can think about this too. If you put peanut butter in the fridge, It's really stiff. It doesn't want to flow. If you microwave peanut butter, it almost starts to melt. It becomes much less viscous. So hotter magma is a lower viscosity. So that deals with our types of magma. On the surface, once that magma gets on the surface, we can have two types of lava, right? And these have Hawaiian names, right? Hawaii is a whole set of volcanic islands, and so the native Hawaiian culture had a couple names for the different types of lava flows that they saw, and we use those terms now worldwide. So the two main types of lava flow you need to know are what are called pahoehoe, right, which is this first one, and the second one is called a'a, right? In the Hawaiian language, you pronounce all the letters, so AA you pronounce a'a. So pahoehoe is very fast-moving, hot lava, so hot temperature, low viscosity. So it looks wrinkly and rope-like. So when you see those rivers of lava, that's pahoehoe. A'a is much cooler and slower moving, and it looks like rough, jagged chunks. And I'll show you some pictures. So pahoehoe is going to look like this. You've got lava flowing down the mountain, just pouring out, and it ends up piling up in like ropey lumps at the bottom. A'a is much rougher and jagged and stiffer, and this whole wall of lava might be flowing, only at a mile an hour, so something where you could easily outwalk it. All right, that is all of your notes for tonight, looking at types of magma and lava. 3 questions at the bottom, and I will see you guys in class tomorrow.